The last thing I want you to notice is going to start from this table. Okay? You remember all of this. That is the probability of the state of nature. Okay? That is the probability of the state of nature. Okay, so you remember all of this. Now, you also remember the regret table. Okay, in case that you've forgotten the regret table, okay, let me just take you back to that regret table, because the next thing we are going to look at, okay, this is a regret table, and it was 50, 0, 0, 70, 70, 20. Okay. But let me rewrite that regret table here, because you're going to use it. So this is a regret table. You have decision alternative 1, decision alternative 2, decision alternative 3. You have the state of nature 1, state of nature 2. Okay. And when you are now finding the table of regrets, you have 50,000, and then 0, and then 0, then 70, then 70, then 20. So that's what you have from the regret table. Keep that in mind. The next topic we are going to calculate, or we're going to work with, is, ladies and gentlemen, it is known as, and this is important, the expected opportunity loss. The expected opportunity loss. And it is the last thing that I wanted to note about. Please note that this expected opportunity loss is always equal to the expected value of perfect information. Who can remind us that answer, the expected value of perfect information? What value was that? What value was this expected value of perfect information? 28. Very good. 28. Somebody is following. Okay. 28. So this was 28. Now listen. The expected opportunity loss that we are going to calculate should match up that figure. But what is expected opportunity loss? Well, remember, the expected, one guy was telling me that regret. And I told him that you got to look at the regret as a loss, but it's difficult to look at it in monetary terms. Because you can regret this way and regret that way, and eventually, so those values were the extent of the regret, those regret tables that we calculated. But now we're going to convert those tables into monetary values. Okay, that's what we're going to do now. We're going to convert the regret tables into monetary values. And that is the essence of the expected opportunity loss approach. So what is the formula for that? And again, you use expected opportunity loss approach for deciding. Okay, for deciding. So we call it EOL. EOL. So let me just write it there. So the EOL, the expected opportunity loss for any decision. Any decision. How do you now find that? It's very simple. It is summing the probability of the state of nature. Probability of state of nature, SJ, plus the regrets. Okay. So I take the probability of the state of nature. That sigma is simply say as is sum. And then sorry, it's not plus, it's times. Okay. You multiply that by the regret table, and you sum it all. You sum it all. Now remember, the probability of state of nature is 0.6 for this one here. In fact, I can put it down or up. Let me put it up here. 0.6. And then 0.4 for the state of nature 2. So I'm going to calculate the expected opportunity loss for decision alternative 1. And the formula simply says that you take the state of nature, the probability of the state of nature, 0.6, you multiply that by what? If I'm doing it for D1, I'll multiply that by 50. Okay, so you take the 0.6, multiply by the loss, the regret table, the regret, then plus the next probability of the state of nature, 4.4, multiply by that regret, which was 0. And that should give you the expected opportunity loss for apartment building. What do you get? What do you get if you should do that? It's a very, very simple answer. Because if you are working it with me, that's how you get. So that will give you a value of 30. Can you do for the others? So calculate the expected opportunity loss for D2. And you can see that anytime we are doing it, everything with the D1, with the D2, with the D2, remember we can always rank them and decide with them. Okay. Then you do the expected opportunity loss with the D3 in mind. Anytime you're doing something along the decision alternative lines, by the way, the first one is 30. Anything you're doing something, the second one, is somebody just calculated that easily as 28. The third one, some people are calculating, others are confused. Why the rest are calculating? Okay. The third one is 50. Somebody just wrote the answers. Okay. So these are the expected opportunity loss. And remember, the word are loss. Okay. So if you are going to decide based on this expected opportunity loss, you got to choose the lowest one, the lowest loss. And so the best decision under the expected opportunity loss is what? Is office building. I didn't say the best decision is 28. The best decision is to buy the office building, D2, because it gives us the lowest loss. Now, so this is the answer here. Do you remember that this was equal to the expected value of perfect information? That's exactly what we said. Okay. So anytime you calculate your expected opportunity loss, okay, and you select it, the best one, make sure that it is equal to the expected value of perfect information. That's it. Make sure it's equal to the expected value of perfect information. So based on this, we can make some conclusion. Anyway, everything we did is here. We can make some interesting conclusions here. The first conclusion is this. And by the way, decision alternative. Do you realize that decision alternative 2, which is office building, has been selected out of the 5 criteria that we have used? It has been selected 3 times. An apartment building has been selected twice. And warehouse has been selected none. Okay. So putting all of these decisions together, okay, we call it robust analysis. Okay. You can now make a conclusion that overall, combining all the potential decisional approaches, the criteria, we can say that office building is a go-to-go. Okay. Is a one to probably select as far as this whole thing is concerned. All right. So the 28 minimum regret is the same as the amount you pay to that person who will give you the best information. Okay. Don't forget that. And that is it. So quick things, quick comparisons here. Because some of the things we've done are quite complex, but quick comparison. 1, the expected value approach, the one which is without perfect information. And then the expected opportunity loss approach, they will lead to the same decision. And if you go and check, you see they all selected office building. Okay, the one which was without perfect information. Okay. This one, which was without perfect information. And then what we just did, which is expected opportunity loss. These two will always lead to the same decision. So take note of that. And both approaches use probabilities, if you have observed. They use probabilities to estimate them. So that is one thing. So it's important that the decision maker, okay, is always as accurate as possible when determining the probability of the state of nature. Because if the probability of the state of nature is wrong in real life, if it is wrong, then that person will do a lot of losses in there. I have some questions here for you to try your hands on. Okay. A BTEA publishing company publishes management science textbooks. that is scheduled for a revision. And these are the revisions. Look at them. Those are them. I just want to show you. Now, in this context, how many states of nature do we have? If you look at just the payoff matrix here, how many are the states of nature? If you look at it carefully, there are 3. And how many are the decision alternatives? How many are the decision alternatives? There are 4. Okay. So on the basis of this, can you now calculate all approaches? Absolutely. Now look at the question. Okay. Determine the best decision for the publisher using the minimax and the maximum approaches. See, the minimax and the maximum approaches. Okay. Now, actually, this word should have been maximum, not minimum. Sorry, yeah, minimax. Sorry, maximax. So the first word should have been maximax and the maximum approaches. Then determine the best decision using the minimalist regret approach. This is the one we created a regret table. Okay. Then suppose now you have the probabilities of the state of nature, and watch it. You have been given the probability of state of nature 2. You have been given the probability of state of nature 3, but you were not given the probability of state of nature 1. I'm sure you can calculate that. Now, having calculated that, now you will be asked, what is the best decision under the expected opportunity loss approach, okay, which is the one we just did. That's it. It's so simple. Now find the expected value of perfect information and compare your results with that in C. And so you will expect that when you should find this expected value of perfect information, that will be equal to the expected opportunity loss that you would have found in the C part. You do that, then you are able to work it out. That will indicate that you understand everything related to that. Ladies and gentlemen, that brings us to the end of the entire caboodle. What a way to end the story on decision analysis. Of course, there are several more topics on decision analysis, but I do not want to bore you so much.